you to understand the definition of transition elements. We are going to learn the series of transition elements, differentiate between typical and non-typical transition elements. We are going to study the general features of transition elements and the electronic structure of transition elements. Students, before starting today's lecture, let us look at the location of D and F block elements in the periodic table. So in this picture, you can see that S block elements are placed on the extreme left side and P block elements on the extreme right side, whereas the D block elements are present in between S block elements and P block elements. And you are going to find the F block elements on the bottom of the periodic table. Students, as we have seen that D block elements are present between S and P block elements, therefore, the transition elements can be defined as the elements which shows properties which are transitional between the electropositive S block elements and electronegative P block elements. Because S block elements are metal atoms, therefore they are electropositive in nature, whereas P block elements are non-metals and they are electronegative in nature. So the transition elements includes the D block elements and the F block elements of the periodic table. Students, on the basis of electronic configuration, the definition of transition elements can be defined as the elements which have partially filled D or F orbitals either in the atomic state or in any one of their possible oxidation states are called transition elements. Students, you already know that if the valence electrons lies in the D subshells, they are called D block elements, and if the valence electrons they lie in the F orbitals, they are called F block elements. Now students, according to the definition, if the elements which are going to have partially filled d orbitals, only then they will be called as transition elements. Similarly, if the f orbitals which can accommodate a total of 14 electrons, but if it is partially filled, only then it will be called as transition element. The d block elements are called outer transition elements, whereas the f block elements are called inner transition elements. Students, now let us study the transition series of D block elements. There are 4 series of D block elements. Since D block elements are called outer transition series, so the first outer transition series starts from scandium, atomic number 21, to zinc, which is having an atomic number of 30, and in going from left to right from scandium to zinc, the 3d orbitals are in the process of filling. Therefore, they are called 3d series. The second outer transition series starts from yttrium, atomic number 39, to cadmium, atomic number 48, and in going from left to right from yttrium to cadmium, the 4d orbitals are in the process of filling. Similarly, students, third outer transition series starts from lanthanum, atomic number 57, to mercury, atomic number 80, and these elements are called as 5d series. The fourth outer transition series starts from actinium, atomic number 89 onwards, and in the process the 6d orbitals are in the process of filling. Students, the general outermost electronic configuration of the first outer transition series of D block elements is given by n-1 D 1 to 10 n s 1 to 2. Now let us apply this general outermost electronic configuration on scandium having atomic number 21. Now students, the electronic configuration of scandium is 1s2, 2s2, 2p6, 3s2, 3p6, 4s2 and 3d1. The formula is given as follows. Now students, over here n stands for the valence principal quantum number, which in case of scandium is 4. So over here, we are going to place 4. 4 minus 1 will give us 3. Now students, D means the D subshell. It can accommodate a total of 10 electrons, and we are going to place electrons on the basis of the element that we are working on. In case of scandium, there is only one electron in the D subshell. So we are going to write 1. Then comes again N, which is the valence principal quantum number. In this case, it is 4. S is having 2 electrons. So we are going to write 2 over here. So the valence electronic configuration of scandium comes out to be 3d1 4s2. Now students, let us look at the transition series of F block elements, which constitute of only 2 series. The first inner transition series starts from cerium, atomic number 58, to lutetium, which is having atomic number 71, which are called lanthanides, and for using 3 electrons. For example, scandium in +3 oxidation state is going to lose 2 electrons from 4s and 1 electron from 3d, and therefore attain a positive 3 charge. Now students, after losing these 3 electrons, it will be left over with no electrons in the 3 orbital. For this reason, the elements of group 2b and 3b are called non-typical transition elements, because after losing 3 electrons from s and d orbitals, they are not obeying the definition that we have earlier studied. There will be no electrons in the d orbitals. That is why they are called non-typical transition elements. So students, we can classify the transition elements as typical transition elements and non-typical transition elements. Non-typical transition elements belongs to group 2b and 3b, which do not obey the definition, in which we have studied that transition elements are those elements which are going to have partially filled d orbitals or f orbitals. So typical transition elements, which are group 4b, 5b, 6b, 7b, 8b and 1p, they are going to have partially filled d or f orbitals. That is why they are called typical transition elements. Now students, let us study some general features of transition elements. The transition elements, they are metallic in nature. Some of the transition elements play an important role in the industries. These metals are titanium, chromium, iron, nickel, copper, molybdenum, tungsten, zirconium, niobium, tantalum and thorium. They are all hard and strong metals with high melting and boiling points. They are good conductors of heat and electricity. They form alloys with one another and other elements of the periodic table. With a few exceptions, they show variable oxidation states. Their ions and compounds are colored in the solid state and in the solution state. Transition elements and their compounds are usually used as catalysts in some reactions, and they form complexes or coordination compounds. So students, these are some general features that we are going to study about the transition elements in this chapter. Students, first of all, the transition elements are metallic in nature. All the transition elements are generally metals because they are good conductors of heat and electricity, and mercury is the only metal which is found liquid at room temperature. Students, the atomic sizes of transition elements decreases to a small extent as we move from left to right in a periodic table. Now, what is the reason for that? It is due to the increase in the nuclear charge without the increase in the number of shells. The number of valence shell remains the same. Only one electron is being added up, but the nuclear charge increases. Therefore, the size is decreased to a very small extent. Students, the ionization potential values of d block elements are greater than s block elements but smaller than the p block elements. These elements may form either ionic or covalent compounds depending upon the conditions. Students, one of the most important property of transition element is that they are having variable oxidation states. Now, transition elements show variable oxidation states in their compounds as well. The variation is due to the very small energy difference between 3d and 4s orbitals, and as a result, the electrons of both 3d orbital and 4s orbitals, they take part in the bonding. That is why they are having variable oxidation states. Students, here is a chart which is showing the variable oxidation states of transition elements. The maximum oxidation state that you can find is in manganese, which shows an oxidation state of +2 to +7. Now students, we are going to study all these oxidation states in the next lecture with their electronic structures. Students, most of the transition elements, they are colored compounds as we have studied in solid state as well as in their solutions. Now the reason behind is the splitting of the d subshells. Now these are the degenerate d orbitals dxy, dyz, dxz, dx square y square and dz square. Now students, during the bond formation, these 5 degenerate orbitals, they split up into 2 energy levels. dxy, dyz and dxz, they are at the same energy level and they are called triply degenerate d orbitals. Whereas dx square y square and dz square is a little higher in energy and is called as doubly degenerate d orbitals or Eg set of d orbitals. Now students, the energy difference between T2g set and Eg set is very small. Now students, the energy difference between Eg set and T2g set that we have discussed is equal to the wavelength which lies in the visible region of electromagnetic radiations. And the visible region is that our eyes can detect, and it comprises of different colors. By absorbing visible light, an electron may move from lower energy level to a higher energy level. The absorbed component of the white light is removed, whereas the remaining component that is reflected back, which we may see, is going to give the color to the compound. For example, students, copper absorbs red light in its +2 oxidation state, and hence the transmitted light gives blue color, and this is the color that we are going to see. You have seen a hydrous copper sulfate which is having a blue appearance. Students, transition elements also possess magnetic properties. Transition metal compounds are mostly paramagnetic in nature. It is due to the presence of unpaired electrons in their ions or in the atomic form. Due to the unpaired electrons, they show paramagnetic behavior. As we have discussed in the general features of transition elements, that they are used as catalysts, so they also possess catalytic properties. Transition metals and some of their compounds are generally used as catalysts. The transition elements in some reaction forms unstable intermediate compounds, and in other cases they provide a suitable surface area where gases can be absorbed. For example, students, you have seen in hydrogenation, nickel is used for hydrogenation of vegetable oils to convert it into vegetable ghee. Similarly, iron is used in the manufacture of ammonia. So over here, these are the two examples of transition elements in which they are used as a catalyst. Students, transition elements are also called interstitial compounds. Transition metals forms compounds of indefinite structure. means they do not have a definite structure, and proportions means tissue-metric ratios, which are called interstitial or non-stoichiometric compounds. The reason is the variable oxidation states and defects in their solid structure. For example, students, small atoms such as hydrogen, boron, carbon and nitrogen. These small atoms, they can reside within the holes which are present in the crystal lattice of the transition elements. So, interstitial spaces are present, and in those spaces these small atoms, they can reside within, destroying the original structure. That is why they are going to have indefinite structure, and the atomic proportions, they are not going to be appropriate because of such elements which can reside in the interstitial spaces of the transition elements. Transition elements also form complexes. Transition metals form complex compounds which are also called coordination compounds. It is due to small and highly charged ions and the vacant d orbitals or suitable energies. These vacant d orbitals accept lone pairs from atoms, ions or molecules which are called as ligands. Students, in this chapter we are going to study all the details of coordination compounds. Now students, the complex molecules are called transition metal complexes. Now what are transition metal complexes? A compound containing the complex ion or complex molecule in which the central metal atom is surrounded by a number of oppositely charged ions or neutral molecules called as ligands is known as a coordination compound or complex compounds. Now students, in the next lecture we are going to discuss in detail all the metal complexes, their nomenclature and their salient features. Students, I hope you have understood today's lecture. Here is a homework from the related topics. Try to answer these questions. Thank you and Allah Hafiz.